Hello. Welcome to my session about charting a virus. My name is Ingeborg Hawighorst and I live in New Plymouth, New Zealand. I'm very excited to be able to talk about this at the Sydney Reactor. I would have loved to come in person, but things being as they are, this won't be possible, at least for a while. So isn't it great to have all that technology at your fingertips that makes it possible for me to just be with you and share things with you, although, you know, the Tasman Sea divides us? Well, let's get a look at what we can do with Excel and Power BI when it comes to creating dashboards with data sources from public places like the web. And the example that I'll be using will be about COVID-19 in New Zealand. Let me just go and share my screen. And we'll use that one. So the background to this is that in March, I was traveling overseas and I returned on the 22nd of March to New Zealand. And by that time, we were, all returning travelers were required to self-isolate for 2 weeks. So I set up shop in my home in my spare room, and next day I started working from home. And I also kept an eye on the numbers in New Zealand about, you know, where is this virus going? What is the development? How long is that going to last? And when can we get out of there? So starting with looking at the websites, I found that the most up-to-date information was on the Ministry of Health website. So every day I would check these and watch the news, see other countries' news and see charts about other countries. But every day all I saw about New Zealand was just text on websites and a few numbers in tables on the Ministry of Health website. And I decided that, you know, if there aren't any charts or any dashboard, I'm going to roll my own because I can. My first go-to tool for anything from shopping lists to heavy data lifting is Excel. So that was where I turned to first. And the screenshots that I'm going to show you today, most of these, when they show the data from the website, that data changes every day, of course. So what I did to retrieve the older versions was I went to the Internet Archive, the Wayback Machine, and I pulled a few things there. And their earliest screenshot is actually a few days into my project here. So I couldn't find, there is no Wayback version of the earliest versions of the data that I'm showing here. So I reconstructed this data set that I used for my earliest chart and dashboard. So I found this table on the Ministry of Health website, and it had columns for for case number, location, gender, age group, and details. And the details was a free text field that had a lot of stuff in there, very unstructured. In order to do anything with that data, I had some serious cleaning up to do. So the location column had a mixture of words in it. Some were Christchurch and Wellington, obviously cities, and then there were regions like Wellington region and Canterbury, and then there were things that didn't really fit at all, like Kapiti Coast. It's not a government region. Southern DHB is a district health board. TBC didn't fit anywhere else at all. So I built an Excel table where I mapped all the values that I found in the location column and decided what I wanted them to be in my visualizations. And I decided to go for New Zealand regions because New Zealand maps, there is a map in Excel that has New Zealand regions in it, and I wanted to use that. Then also we had gender that had female, male, or F and M, so I quickly cleaned that up with a couple of find and replace commands. And we had the age group, which says teen or 20 to 29, and I found these labels a bit long, so I just replaced them with teen, 20s, 30s, and so on. That is the first set of charts that I built in Excel. So I have a table by region that I took from the website. It was in that format with the region sorted like that, Auckland through to Tasman, and then the other data that I just explained from the other table that I found there. So how did I do the map in Excel? Excel has this tool called Filled Maps. It's a filled map chart, and it can plot areas, regions. It cannot plot points, so I cannot put a pin in that map for Auckland or Wellington. I can only use the shading for those regions. And let's just have a look at those. That's a few niggles that I have around those maps that I'm walking you through here. That when you want to create a map, you need a value for the area or the region, and you need a value for the color that you want to apply. So how dark the color is or whatever. So you need a numerical value that you can plot on the chart. Excel maps are very, very sensitive when it comes to how you name your column, because when you use that, so I thought, you know, region is Northland, Auckland, these are the names of the regions, and then I put the value against it, and then when I create a map, I should have Auckland and Northland regions plotted on the map. But what you get is an error message that says map charts need geographical data. Well, I have geographical data, so what really is the problem? I quickly found the solution for that because I've been working with map charts for the last 3 years or so since they've been in beta. And the thing that you need to do is you need to add an S to the end of region so that it is regions. And then when you have that S at the end, it actually finds the thing that you want to plot on the map. It's a bit of a, you know, gymnastics. I don't really know why, because in the normal convention, when you have a data table, your column headings normally don't say products, names, dates. You say name, product, date, but okay, we have regions and that works. So let's roll with that. The other peeve that I have about the map is the New Zealand map takes up a huge space in the chart, and there's a lot of white space around in the plot area. You cannot zoom into that plot area. And it is really hard to, you know, find what you're looking at. And one reason that I found why the map is so big is where that arrow is. That's the Chatham Islands. They belong to New Zealand. So this is a map of a politically correct map of New Zealand islands and territories. But I still don't know why we have such a lot of white space to the left or at the top. I then use it, but so be it, you know, that's just what I need to work with. And in order to make sure that I'm spelling all the regions correctly, I just used a list of all the regions in New Zealand and put in a 1 next to it, and that means that if any of those regions do not light up in blue, I've not spelled them correctly. So that's how I construct my base map, and then I know I have the values correct, and then I can start filling in with the real data. Now, the way that I integrate this New Zealand chart map into a dashboard requires a few tricks as well. The yellow outline that you see here, that is the boundary of the chart. And the green line that you see here, that is the boundary of my dashboard. So I make the map chart really, really big, and then get it all the way up to start in row 1. And the usable part of the map is around row 7 of the Excel grid. So I then freeze the panes at row 7 to hide the first 6 rows. And that will then show the map only, you know, will cut off the top part of the map, and then I can place other charts and visualizations and tables on top of the map chart. And if I make the map chart transparent, the background of the chart area and the plot area, I can even use Excel tables in the background. And that is what I've done here, where you see the list of regions and the numbers for that. That is actually done with conditional formatting data bars inside the Excel worksheet. and not a fancy chart that is put on top. So this is the worksheet, the grid peeking through the transparent background of the New Zealand map chart. So looking at that, I thought, you know, this shows me one snapshot in time, and I actually wanted to see a development over time. Where is this going? So I wanted some more history. So I dug around a little bit and I found data on Wikipedia. I didn't really feel like going through dozens of individual news articles and writing down the numbers. So I found this table in Wikipedia. That is what the table looked like in Wikipedia on that day, on the 25th of March. And it had the buildup of case numbers in New Zealand. So I just copied and pasted that data into an Excel spreadsheet with the dates against it. And I put in a few columns so that I could calculate from the total numbers reported, I could calculate what the new numbers for that day were, and I also added columns for recovered and for deaths, and I could calculate the number of active cases. I put all that into a spreadsheet and saved that on my OneDrive or a SharePoint site, and then I could use that every day. While the press conference was going on and while the new numbers were announced, I would just add a new row to this data and put in the numbers for that day. That was one of my data sources. And that was the first version of the dashboard in Excel that I was fairly happy with. We now have a horizontal bar chart for the breakdown by regions, and it is broken into confirmed and probable cases. So this is just a stacked horizontal column chart. We have a line chart for the case development at the top right, and it shows the total cases. And we have other column charts for daily new cases, and we have a few charts for the age distribution and the gender distribution. Cool. The next day, the table that I used from the web was changing its layout completely. They look well, not that completely. They replaced the location column with a column that they labeled DHB, and they now had more consistent data in that column, and they used the names of the district health boards, which are very similar to the names of the regions in most cases. So I could throw away my mapping table saying that Christchurch is in this region and Hamilton is in Waikato. So I could throw that table out because now the DHB column would give me the information that I needed. But there was a problem with the data quality. When I looked at the table on the right, which is the table with the details, and the table on the left, which is the table that is the breakdown by region, I found that there were quite a few issues. So for instance, Nelson Marlborough, there was in one table it was spelled with a dash and in another it wasn't. And Capital and Coast, some use ampersand and some used the and word. And then we have special characters, the Maori macrons across the A, the little dash across the A that was in one table but not in the other. And then I found about four different spellings of Hawke's Bay with the character they used for the apostrophe. So it's totally understandable. Tensions were running high. There's people involved who are typing this data in manually, and that is why we do use tools for data validation when we want to have high quality data. So in this case, I just had to adjust and do a few gymnastics after pulling the data into Power Query and do a little bit of a cleanup and find and replace so that the data was consistent across the board. But a much bigger challenge occurred with this new format with the map, because the New Zealand government regions, which are on the left-hand side in the colorful map, do not always coincide exactly with the district health board regions, what they cover. So for instance, at the southern tip of the South Island, you find that both the governmental regions Southland and Otago get rolled up into one southern district health board. So that would be okay, you know, if I found no, it's not okay, because if I get a number from the Southern District Health Board, into which area of the South do I plot it? Do I plot it in the Otago region or into the Southland region? So these decisions, I felt no longer comfortable making these calls saying, you know, we have a totally different layout of how we divvy up the country, and I can no longer use the areas to plot that. And I didn't have the tools to draw my own custom regions. And you cannot do that in Excel. So I found it was time to move to do something else, and I told Excel to move over and make way for Power BI. This in itself is not a bad thing to do, because it is very, very easy to port work, especially the query work, from Excel to Power BI, because both systems, Excel Power Query and Power BI Power Query, use exactly the same language. I could easily just open the Power Query advanced editor, copy all the code that Power Query generates automatically when you configure a query, and just paste that into a new blank query in Power BI, and boom, everything was there, everything was in place. And then I just needed to start creating helper tables and relationships, and then I could use them in visualizations. So for the chart region, I wanted to plot a point on a map in Power BI. So Power BI has maps where you can plot points on the map, and the size of the plot point can indicate values, how big or small something is. So now I decided to create a location mapping table where I would use the DHB name and map that to a location in the map. So for some regions, like Southland, I arbitrarily chose a point on the map that is somewhere in the geographical middle of that region. So for instance, where you see this green circle in the slide here, that is where for the Southern DHB I used Lumsden. That's a little place in the middle of nowhere. Or for South Canterbury I used Duntroon, which is somewhere in the middle of South Canterbury, and I plotted the circles on the map in that position. And this is what it looked like. And I have, this is the first very crude version in Power BI. And later that day, I changed it around a little bit and added a few more details. And on the end of 26th of March, I published this in Power BI. So I saved the Power BI desktop file as a PBIX file, and I published it with the publish button up into the Power BI service in my tenant. And from here on, I could then not share, but publish this to the web. To do that, your report has to be in the service, and your company administrator needs to enable publishing. I'm the master of my tenant, and I was able to, create all the settings and push all the levers in the right directions and publish this to the web. All the underlying data of a published report is visible to the public, and it's sometimes not advisable for internal corporate data to be published on the web, and that is why a lot of companies have turned this publishing feature off. And if you are just a regular user of Power BI and you do not have administrative access to features to turn them on or off, you may find that you do not have this command to publish to the web. The reason for that is that you cannot, your company administrators have this policy, you're not allowed to publish your company's data. I mean, it really can be dangerous. You can inadvertently copy your last financial internal statements or whatever, and the whole world can see them. So it's quite understandable that companies don't want to use that. Do not confuse this publishing to the web with sharing reports and dashboards inside your organization. That is a completely different thing. So publishing to the web makes your data public, but sharing reports and dashboard inside your organization is completely safe, and your data will stay inside your organization. Just want to say that. So the next day I removed the cheery green from the charts, and the Ministry of Health added the probable cases to the overall totals. So I had a little bump in my numbers. I added a timeline slicer so people could move back and forth in time to a specific day. And I changed the plot points to the DHB headquarters, because I found then when people were clicking on the dot in the map, and the map would zoom in and they would find themselves in the middle of nowhere, they were wondering, why does this place have so many cases? You know, that just didn't make sense, and people didn't understand that I was just meant this to be representative for the whole region. So I decided to use the District Health Board headquarter locations as the plot point for their respective data, which made a lot more sense. The next day, we had a new table layout, and that table layout was radically different. It used a report date. We no longer have a case number, but we have a report date instead. Gender was renamed to sex, age group was still the same, DHB was the same, but now we have new columns where this previously freestyle text was split up into more structured columns for whether or not the case was related to overseas travel, what the last city before New Zealand was, a flight number, and a departure and arrival date, which is quite useful because that meant that I could, you know, people who were interacting with my dashboard online could now look for a specific flight number on a specific date and see whether or not they had on their flight home, they had anybody who was diagnosed with COVID. And I actually found out that the flight that I returned to New Zealand with, there was a person on that flight who a few days later was diagnosed with COVID-19. So yeah, I was pretty close to it. So I needed to create a few new Power Queries to because they now also split it up into a table for confirmed cases and a second table for probable cases. So I created a new query where I got my probable cases and added a column that said this is the status is probable. Then another table where I pulled just the confirmed cases and added a column for status equals confirmed. And then I just appended the probable cases to my confirmed cases table. And this is what the table basically looked like in the end. And I call this table has the name confirmed, but it actually contains both confirmed and probable cases. So whenever I speak about my confirmed cases data table from now on, it also contains the probable ones. So we have the report date, the cleaned up ages, and flight numbers and stuff all nicely sorted. I also have the timeline table, and that is the Excel spreadsheet that I showed you earlier, which lives in a SharePoint library. And that is the one that I manually updated every day with the numbers, the new total, and would then the spreadsheet then calculates the daily new and so on. That is what again what it looked like at the end of that day. Now, I want to have a look at some of the charts here, a little deeper look in what that actually, how they were constructed. So for the age distribution, I changed the value of the 50 to 59, 20 to 29, did a find and replace to use 40s, 20s, 30s, and so on, and teens and all that. And when I used that in a chart, though, on the axis of a chart, I wanted this to be sorted in a particular order. So I have child, teen, and then 20s, 30s, and at the end I wanted unknown, and I didn't want this sorted alphabetically because then unknown would have ended up somewhere after teen, or I think child would have ended up after 80 years old. So I didn't want the alphabetical sort, and in order to achieve that, I created a helper table, and that is the age table that you see on the very right. And here I just have the same labels that I use and another column that I call sort, and that column has just the numbers in the order in which I want these words to appear in a sorted area. And in Power BI, in the modeling, I can then tell it to sort the age column by the sort column. So select the age column, click the sort by column command on the ribbon and select the sort column. That means whenever I use this age table and I pull the age column into a visual and have it sorted by that, it will actually use the sort order of the sort column and not the alphabetical sort. I hope that makes sense. In the data model, I then build a relationship between the age table and the confirmed table on the key field age. And then I can pull from the field list, I pull the age from the field list table, sorry, the age field from the age table and the total cases from the value table, and that will give me this wonderful chart where that is like a histogram or an age distribution for all the cases. Let's take a closer look at the map. So we have the table is called DHBs, and I gave the plot point. I created a column where I said where the plot point should be. So this is the headquarter of the DHB. So we have the DHB column next to it. And so I said, okay, Auckland DHB plots at Auckland, New Zealand, Bay of Plenty DHB plots in Tauranga, Canterbury DHB plots in Christchurch, and so on. And then the DHB table, this helper table with the DHB column, gets connected to the DHB column in my confirmed cases. And then I can use a visual and pull from the DHB table, I pull the plot column into the location, and I pull the DHB name into the tooltip, and I pull the total case number into the size. So the size of the bubble will come from the total cases, the breakdown will be by the plot point, and the DHB name will be visible in the tooltip. Now you see in the tooltip also that it says DHB HQ. It doesn't actually say plot, and that is because you can rename the labels of the columns once you have dragged them into the visuals. That is very important. You do not have to use the names as they are in your tables. And that can be quite a powerful tool because you might have tables with similar columns. You might have tables with system naming conventions. And if you don't want to use that table as it comes from your SQL database or from somewhere else, you can actually rename that column while leaving it intact in the table, because you might need that weird name for identifying the correct column. But once you've pulled it into the visualization panel, you can use the little drop down arrow and then rename that column to whatever you want it to show in the visual. And then dates. Dates was something that I used in a lot of the charts. And I created a date table because then I could use that date table and I could make sure that I have a consistent date range and no gaps in my dates. And the quickest way to create a date table is actually in Power BI using DAX. So you start on the table tools and you create a new table with the ribbon command, and it will start out like table equals in the formula bar. And then you just go and put in another formula. By naming the table from table to date table, that creates the name of the table. And then by using this calendar function, you actually create a calendar from the start date to the end date. So the start date was, for me, I wanted to use the 26th of February 2020 because that was the first coronavirus reported date in the source data, and I wanted the last date to always be the current date, so today. That means that I didn't have any dates going into the future, and that all my charts none of my charts would actually go into the future, and everything would be nicely cut off at the correct date. Then I could create relationships between all the tables and use the date column in the timeline and use the report date column in the confirmed table to link back to the date table. Date tables are very useful then when you want to group your data by different aspects. My date table only has one column, but I could add more columns to that date table, like the year or the financial year or the month name or the calendar week and stuff like that. And then I would be able to group my data by calendar week or by a month or other places, other aspects. So a date table is essential when you work with time data. So here is the date table in action. I take the date from the date table and pull it onto the axis of my visualization, whereas other fields come, for instance, from the timeline table in this case, where I have the sum of the active and the sum of the recovered cases in the values area, and that is the line chart that you see in the middle there with the blue, with the black and the green line. But you see that I also have time axes on two other charts, and I didn't have to rebuild any formatting, all that. I could use the date table over and over again. So that's what we looked like on the 28th of March. On the next day, the table headers were changed in the website table. My query refreshed through an error, and I couldn't figure out what was going on until I looked back on the web and I found that they had changed the report date was now called date of report, and the last city before return or before New Zealand was now called last country before return. So I fixed up the query, the data refreshed, and the next day they changed the table headers again. So now it was last country before New Zealand instead of last city before New Zealand. Yeah, the next day they changed some of the table headings again, and by that time I've had enough, and I thought, you know, there must be a better way to do that, really. So what I did was I imported the data, and by default Power BI does a little bit of intelligence and looking at the data, and if it thinks that the first row of data might be headers, then it will use that command to use the first row as headers. You can either reverse that command by deleting it from the Power BI command list, or you can even make that, you know, reverse that by saying, no, use the headers as the first row of data. In any case, I did not want Power BI to use the first row as headers, so I removed that command and I told it to use the headers as the first row instead. So it would then call all the columns, column 1, 2, 3, 4, and the headers that were changing every day were now in the first row. So the next step would then be to use the remove rows command and remove the top row, and I removed the first row of data, and then I could use the rename command to just rename the columns the way I wanted the column names to be, and from then on it was smooth sailing, and I never had to look at those column names again. The next day was the 1st of April, and I could just refresh my queries and everything went super duper, no problems at all. But it was because it was April Fool's Day, because after that we had more problems, because next day they swapped the positions of two columns. So my queries broke again, and I can do all the column renaming that I want to, but if they swap the columns for arrival date and flight number, that's nothing I can fix with renaming. So I had to fix my query again. Now, the next day, I found that when I refreshed my query, I had a very weird result. And I found that the total cases by DHB, which I pulled from a table on a website, it used to be the second table on that web page, and it now moved positions to. You see here that it is in row 2. Just disregard the highlight for the time being. It used to be in row 2, total cases by DHB, but it no longer was. The next day, it actually changed. So I used the second table, and the command to do that was source 1. This is a source 1 is a 0 index, so source 0 would be the first row, source 1 is the second row. So that is what I used. But by the next day, this second table on the page was total cases in hospital and not total cases by DHB. So I decided to use a different approach, not the position of the table on the page, but I tried to identify the table that I need by its name. So you see in the caption that these tables are named something. So it's called total cases by DHB, followed by a timestamp and a date. So I thought, okay, I might be able to filter this by the captions and just look at the total cases, look at only the row that says total cases by DHB. So filtering by something like this and disregard the rest. So that looks like this. If the caption column contains the text total cases by DHB, give me that one and then work with the table that is in that row. And that kind of worked. Oh, and the other thing that they did on that day, they swapped the columns back, so I had to fix that again. On the next day, they had a name change in the, no longer called it total cases by DHB, but number of cases. So this table here, I still use the headings, but that was an easy fix and I wasn't faced too much. But on the next day, I had totally weird numbers. My totals were going through the roof, and I found that through some fluke of copy and paste or something, there were 2 versions of the confirmed cases table on that website. So somebody must have pushed the Control V paste button twice or something, and it was twice in there. I don't really want to fix that with doctoring around my query, so I decided instead of using the website table to download the Excel file and use the Excel data from now on. The Excel spreadsheet has 2 sheets, one for probable and one for confirmed cases, and it was just an easy fix to download the Excel spreadsheet and point my query to the downloaded version of the Excel spreadsheet. I would have wanted to actually pull the Excel spreadsheet right from the web, but there was a challenge with that because the file names that they used differed quite considerably every day. I'm not sure if it was just different people updating that file or the same person who just doesn't have a concept of what naming conventions are or why we want to use naming conventions. So I could not automate pulling the file name directly from the web because it was just too unstructured and I couldn't anticipate what variation of file name they would use. So I really had to go in there every day, wait for the data to be up to date in the online spreadsheet, and then download that spreadsheet, rename it to the name that that my query expected the spreadsheet to be, and then reconnect that. So that meant, every day I really had to go in and manually do something to refresh my data. Then we have a few layout changes here. I have, in this version here, I have added a series to the daily new cases. That is the chart on the right-hand side in the center. in the horizontal, in the vertical center, because the numbers that they announced at the press conference sometimes included, well, they look different when you compared them to the table in the text table in the middle. So the day that they reported a case was not necessarily the date that ended up as the report date in the table. So I gave both versions of the numbers in this table here, in this column chart. On the 12th of April, I found that the table on the website now only contained the confirmed cases for April, and the cases for March and earlier were now only found in the spreadsheet. So I thought, wait a minute. That means that if I download the Excel spreadsheet once, then I have the data from before April, and I can combine that with the data for 1st of April and after from the web. So I can mash that up, and then I do not have to download a file every day. I thought that was a brilliant idea. So I did that, downloaded the spreadsheet that had the data. I said, okay, ignore everything in the spreadsheet that is 1st of April and later, and grab the data from the web for which has 1st of April and later, and combine that with the data I have from the spreadsheet. So with that, I could just click a simple refresh button once a day and didn't have to download and rename files. It was a brilliant idea. Only next day I found it didn't work. The numbers didn't match up. So even though we were in the middle of April, they were still changing data for the March numbers. They were still updating March data while we were in April. So the overall totals of my version didn't match up with the overall totals that they were showing on the website. So I reverted back to my manual downloading of the spreadsheet and not using the web page data at all. Then by 16th of April, we finally had new data in the breakdown by region. The long-awaited recovered and deceased cases were now identified by region, and that means I could add that to my web table and my visualization, because that is what we were lacking in the dashboard. We couldn't quite see how the regions were progressing. They were only showing the total cases by region, but not how many people were recovered in each region. So it was a quick query adjustment, and I added a new measure and added that to the stacked horizontal bar chart, and also to the map chart. So what you see here is some fresh green. That means these cases are recovered by that time. So the bubbles on the map turned into little pie charts that have wedges for recovered, active, and the red one for deceased, which is thankfully just a very narrow sliver in some of the charts. And this is the last data refresh that I have, and it is that one was refreshed on the 29th of April, and I published this dashboard, and you can still see it. I did a few refreshes after that, but this is the screenshot from the 29th, and I published this. You can see the bit.ly address here, and it's COVID-19 NZ with a capital C and a capital NZ. And you can still find that, and you can have a play around with that. This is the end of my slideshow, really, and I just leave that up so you can take note of the bit.ly address while I try and get to the Q&A. I would like to see if there's any questions, but I'll hand it back to Nadia for the time being.
Thank you for that, Ingeborg. That was such an eye-opening presentation. Interesting to see all the data that you've put out. So thank you for that. So while Ingeborg is going through the Q&A, I'm just going to take you through what we've got coming up at the reactor, and where you can find out more information on the events that we do have up and coming. So I'm just going to share my screen with you all. Okay, so if you want to find out about any of the events that we do have coming up, you'll be able to find them at meetup.com/Microsoft Reactor Sydney. You'll be able to see our global events as well on our Twitter page, which is MSFT Reactor. So up and coming, we've got a session called Blockchain Fundamentals coming up actually tomorrow. So this is a good session for anyone who wants to learn more about the fundamentals of blockchain and how it's changing the way we deal with currency and transactions. So that's going to be done on our Twitch channel. We've also got a session called Adding AI to Your Applications, and this is going to explore how you can take advantage of pre-built models, adding them to an application using Python. So some basic Python knowledge will be useful for this session. And we've also got another one called Not Your Other Data Center. So one of our MVPs, David, will take you through some 10 tips for successful Azure migration. So with that, I'm going to hand it back over to you, Ingeborg, to do the Q&A.
Right, thank you. So I have a question here from Anonymous saying that, where is the data stored in Power BI? It is stored in the Power BI file, in the PBIX file that you create with the Power BI desktop application, and Power BI has a very efficient compression algorithm, and when it pulls the data from web, from queries, from SQL Server, from Excel spreadsheets, it can compress them very efficiently so that data from that would take up several megabytes, dozens of megabytes in Excel, for instance, end up to be just 1 or 2 megabytes in the compressed file in the Power BI file that you publish to the web. Then there are other ways to connect to data with on-premises versions where actually the data is never really pulled into Power BI, but continues to live its live queries that pull the data while you refresh your filters on the dashboard. But that's a different story for corporate environments. Another question, also by an anonymous user, is that you mentioned that Excel and Power BI use the same language when moving your data to Power BI. What language is used in Power Query? The language used in Power Query is called M, capital M. And it is a query language that is used to, it's very different to Excel formulas, whereas the language that you use to create your measures and your calculations in DAX is very similar to Excel functions, and there are quite a few DAX functions that are almost the same. But M, the Power Query language, is a totally different concept, and it may take quite a while to get used to that if you want to type out DAX code, Power Query M code yourself. But the good news is that in most cases you don't have to, because a lot of the things that you can do with Power Query is done by clicking on icons in the ribbon. So 99% of what I did for this dashboard was click icons in ribbons. And only in some cases would I go into the code and adjust the formula or adjust something in the advanced code editor. But in most of the times you don't need to do that. So the language is called M, and you can find the it's a little bit hard to Google for M, but if you Google for Power Query, you will find resources about the M language. And Data Messe found a link to my dashboard somewhere else. Yeah. So another question is, what did you find most challenging with this project? It was really at the beginning, I thought, I set this up once, and then I have a data gateway installed, and I put up a refresh schedule for the data gateway, and the press conference is daily at around 1 p.m. So I gather the data will be updated on the website within 2 hours of that. So and then I just schedule my refreshes and lean back and relax and enjoy the dashboard. But it wasn't that, you know, I had to really go in there every day and check and see if something had been messed up, if something had been renamed. You know, I really learned a lot about error codes in Power BI, and you think, you know, what is this and why is this happening? So the challenge was really to deal with, and I think most of it was human factor, because if this had all been produced by machines, I wouldn't have had all those challenges. So the thing at the very beginning where I found 4 different spelling of Hawke's Bay with an apostrophe or the backtick or duplicate S and stuff like that, so that it's just, there is this old adage that says, you know, computing could be so easy if humans weren't involved. So yes, the biggest challenge in this was human beings impacting the data quality. But again, this is all about human beings creating data, consuming data, and human beings suffering from a virus that is ravaging the world. So yeah, my pain was small compared to what other people are going through. And I have some nice feedback here about people liking this step-by-step, and well, thank you very much for acknowledging that. And this is, there's a new one coming in. Okay, yeah, that was just another praise and impressive. So yeah, thank you very much for taking the time to watch this session here from the comfort of my own home. Just want to see, I love Excel. I should have changed into the Power BI t-shirt halfway through the presentation, but I couldn't be bothered. So thanks for coming. That was me.
Thank you for that, Ingeborg. And if you have any feedback that you'd like to give for the session as well, I will just pop up the survey for you. I'll also pop the link in the chat. But other than that, thank you for joining, and we'll see you for our next session. Bye.